All right, so this is the first section of Chapter 2, and the introduction part is basic chemistry. You all have taken chemistry, or you should have, so you should probably have a pretty good understanding of this stuff, so I'm going to do a fairly quick review. So matter. Matter is the stuff that makes up the universe, and it's the definition of matter, which you probably learned in chemistry, is anything that occupies space and has a mass. It might not necessarily be visible because of our different forms of matter, but it's something that we can see. Our matter exists in three forms, which is solid, like our bones or our teeth would be a solid. Liquid would be like the plasma in our blood or our interstitial fluid that our cells are bathed in. And gas would be our respiratory gases like oxygen and carbon dioxide. So again, three states of matter: anything that has a mass and takes up space, So we've got our solid, like a bone, teeth; liquid, like plasma; interstitial fluid; and then gas, which is, the atmospheric air that we bring in, and more specifically, the gases that we're concerned about are oxygen and carbon dioxide. So we can change states of matter. So we can go, in terms of a physical change. So we've got two different basic ways that we can change matter. We can do either a physical change or we can do a chemical change. So with physical change, we're not changing the chemical makeup of the structure itself, we're just changing the form that it's in, okay? And the classic example you probably have been given in chemistry is, melting ice into water. The chemical formula is still H2O, regardless if it is a block of ice, water, or even if it's steam, it's still water, chemical formula H2O. A chemical change occurs, however, when we alter the chemical composition of that substance. So it's no longer the same chemical formula. And again, the example that seems to be classic in chemistry is when we take grapes and ferment them to make wine, so we end up making alcohol, something totally different than what we started as. When I think of physical and chemical change, I think about digestion and the digestive system. So when we put food in our mouth, we do what's called mechanical digestion, or maybe we can call it physical digestion, where we are chewing that food down. So if we put an apple in our mouth and we start chewing it, it's still an apple, but we're just physically crunching it up into smaller pieces, mashing it up, making it goo. When it becomes a chemical change is when enzymes attack that apple and break that apple down into its building blocks, okay? So we actually have two different types of digestion. We have what's called mechanical digestion, which in this case we could potentially even call physical digestion, and we have chemical digestion, which involves enzymes that change the chemical structure of what we're dealing with. So if matter is the stuff of the universe, then energy is the effect on that matter, okay? So energy isn't something that has a mass, it doesn't have a volume, but we measure it based on how it affects matter, what it does to matter. And we have kind of two different forms of energy. Energy can either be stored in the form of potential energy, and then we have energy in motion, which is kinetic energy. And an object can have both potential and kinetic energy depending upon what's happening to it, okay? Potential energy for us is the reason why we eat. We eat food so that we can break the energy that is stored in food bonds. We will capture that energy in order to do either, mechanical stuff or chemical stuff, and I'll talk about that in a minute. Okay, but kinetic energy is actually, it's energy in motion. It's something physically happening, versus potential energy is stored waiting for something to happen. And this is just a long diatribe. I'm not going to read the whole thing, but it talks about, kind of how the same substance, excuse me, can have both potential and kinetic energy. So if we have water at the top of a waterfall, that's when the potential energy is at its highest. And as the water starts to fall, the potential energy gets converted into kinetic energy, and the kinetic energy will end up becoming zero when that water reaches the base or the bottom of that waterfall. And that's how we use, hydro, water things to end up creating stuff like electricity. All right, so there are basically 4 forms of energy that we're going to talk about in their relationship to the body. And the first one is chemical energy, and basically this is energy that is stored in bonds. And like I just talked about with food, we eat food not because it tastes good, but because we want to actually liberate that potential energy that's in the food bonds, and we're going to use it to end up making other substances that will allow us to have kinetic energy as well as electrical energy. Speaking of electrical energy, so an electrical energy in your house is basically so I'm talking about a house, a structure, a house, or when electrons are flowing along a wire. In us, it happens with ions, and ions are charged particles. So something you might see is, K plus or Na plus. So those are sodium and potassium ions. They travel via electrical currents in us, okay, in our cells. And they cause these things called nerve impulses, which basically enables your body to function. If you have an imbalance of, say, sodium or potassium, it could cause a malfunction of your nervous system, which could be catastrophic for you. So electrical energy is in the form of ions moving around our body. Mechanical energy is directly involved with moving stuff. And the best way I can explain that one is your muscles. So your muscles are physically attached to your bones. When the cells individually contract, they actually cause your bones to move. So that is energy in motion causing mechanical energy. Okay, chemical energy will end up creating mechanical energy. Why? Because we need to take energy from our food to turn it into ATP, which is kind of our chemical energy currency. We use the chemical energy that we liberate from ATP in order to cause our muscle cells to contract and shorten, which will then, move that chemical energy into mechanical energy. So again, mechanical energy is physically energy in motion. And then finally, we have radiant energy, and that's dealing with the electromagnetic spectrum. What's kind of cool is that when you're looking at stuff with your eyes, you're receiving light waves, and your eyes are able to take that radiant energy, and they actually have a membrane in them that convert it into electrical energy, because that's how impulses and signals get sent around our body. Additionally, our body is able to take sunlight, that radiant energy, and help us in our skin convert vitamin D into a usable form. And vitamin D is a really important precursor to cholesterol, which is also a precursor to different steroid hormones within our body. So again, those are the 4 different types of energy. Energy can be converted from one form to another. The efficiency of that is not 100%. We know that energy cannot be created nor destroyed, but some of it might be lost, and it's lost in the form of heat. So we didn't get rid of it anywhere. It's not usable at this point because it's being lost as heat. And you can feel that, in a light bulb that's been running for a while, it starts to get hot. You can feel it in your skin, okay? When we're doing all these chemical reactions and when we're converting energy to one form to another, we end up losing, some of that energy as heat, and we can feel that on our skin. That's why we are warm-blooded, is because of all the chemical processes that are going on, and conversions of energy in our body give rise to the heat that we feel. All right, I'm going to stop here.